Dimensions and drawings. Dimensions. Dimensions are applied by means of dimension lines, extension lines, chain lines, or a leader from a dimension, note, or specification directed to the appropriate feature. A dimension line with its arrowhead shows the direction and extent of a dimension. Numerals indicate the number of units of a measurement. Dimension lines should be broken for insertion of numerals. Dimension lines shall be aligned if practicable and grouped for uniform appearance. Dimension lines. Dimension lines are drawn parallel to the direction of measurement. The space between the first dimension line and the part outline should not be less than 10 millimeters. The space between the succeeding parallel dimension lines should not be less than 6 millimeters. The dimension line of an angle is an arc drawn with its center at the apex of the angle. The arrowheads terminate at the extensions of the two sides. Extension lines. Extension lines are used to indicate the extension of a surface or point to a location, preferably outside the part outline. Extension lines start with a short visible gap from the outline of the part and extend beyond the outermost related dimension line. Extension lines are drawn perpendicular to dimension lines. But where space is limited, extension lines may be drawn at an oblique angle to clearly illustrate where they apply. Where oblique lines are used, the dimension lines are shown in the direction in which they apply. Extension lines continued. Wherever possible, extension lines should not cross one another nor cross dimension lines. To minimize such crossings, the shortest dimension line is shown nearest the outline of the object. Where extension lines must cross other extension lines, dimension lines, or lines depicting features, they are not broken. Where extension lines cross arrowheads or dimension lines close to arrowheads, a break in the extension line is permissible. Chain lines. Where a point is located by extension lines only, the extension lines from surfaces should pass through the point. Where it is desired to indicate that a limited length or area of a surface is to receive additional treatment or consideration within limits specified on the drawing, the extent of these limits may be indicated by use of a chain line. In an appropriate view or section, a chain line is drawn parallel to the surface profile at a short distance from it. Dimensions are added for length and location. If applied to a surface of revolution, the indication may be shown on one side only. Chain lines continued. If the chain line clearly indicates the location and extent of the surface area, dimensions may be omitted. Where the desired area is shown on a direct view of the surface, the area is section-lined within the chain line boundary and appropriately dimensioned. Leader lines are used to direct a dimension, note, or symbol to the intended place on the drawing. Normally, a leader terminates in an arrowhead. However, where it is intended for a leader to refer to a surface by ending within the outline of that surface, the leader should terminate in a dot. Leaders. A leader should be an inclined straight line except for a short horizontal portion extending to the mid-height of the first or last letter or digit of the note or dimension. 2 or more leaders to the adjacent areas on the drawing should be drawn parallel to each other. Where a leader is directed to a circle or an arc, its direction should be radial. Dimensioning features. Click each number to know more about various dimensioning features. Diameter. The diameter symbol precedes all diametral values. Where the diameter of a spherical feature is specified, the diametral value is preceded by the spherical diameter symbol. Center of radius. Where a dimension is given to the center of a radius, a small cross is drawn at the center. Extension lines and dimension lines are used to locate the center. Where location of the center is important, the drawing must clearly show that the arc location is controlled by other dimensioned features such as tangent surfaces. Center of radius continued. Where the center of a radius is outside the drawing or interferes with another view, the radius dimension line may be foreshortened. That portion of the dimension line extending from the arrowhead is radial relative to the arc. Where the radius dimension line is foreshortened and the center is located by coordinate dimensions, the dimension line locating the center is also foreshortened. True radius. Where a radius is dimensioned in a view that does not show the true shape of the radius, true R is added before the radius dimension. Multiple radii. Where a part has a number of radii of the same dimension, a note may be used instead of dimensioning each radius separately. Spherical radii. Where a spherical surface is dimensioned by a radius, the radius dimension is preceded by the symbol SR. Chords, arcs and angles. The dimensioning of chords is done as shown. the dimensioning of arc is as shown. The dimensioning of angles is as shown. Rounded ends. Overall dimensions are used for features having rounded ends. For fully rounded ends, the radii are indicated but not dimensioned. For features with partially rounded ends, the radii are dimensioned. Where corners are rounded, dimensions define the edges and the arcs are tangent. Outlines consisting of arcs. A curved outline composed of two or more arcs is dimensioned by giving the radii of all arcs and locating the necessary centers with coordinate dimensions. Other radii are located on the basis of their points of tangency. Irregular outlines. Irregular outlines may be dimensioned as shown in the two drawings. Circular or non-circular outlines may be dimensioned by the rectangular coordinate or offset method. In Figure 1, the coordinates are dimensioned from baselines. Where many coordinates are required to define an outline, the vertical and horizontal coordinate dimensions are tabulated as shown in Figure 2. Grid system. Curved pieces that represent patterns may be defined by a grid system with numbered grid lines. Symmetrical outlines. Symmetrical outlines may be dimensioned on one side of the center line of symmetry. Such is the case where, due to the size of the part or space limitations, only part of the outline can be conveniently shown. One half of the outline of the symmetrical shape is shown, and symmetry is indicated by applying symbols to the center line. Round holes. Round holes are dimensioned as shown. Where it is not clear that a hole goes through, the abbreviation through THRU follows a dimension. The depth dimension of a blind hole is the depth of the full diameter from the outer surface of the part. Where the depth dimension is not clear, as from a curved surface, the depth should be dimensioned. The various methods of specifying blind holes are as shown. Slotted holes. Slotted holes are dimensioned as shown. The end radii are indicated but not dimensioned. Counterbore holes. Counterbore holes may be specified as shown. Where the thickness of the remaining material has significance, this thickness rather than the depth is dimensioned. Holes having more than one counterbore are dimensioned as shown. Countersunk and counter-drilled holes. For countersunk holes, the diameter and included angle of the countersink are specified. For counter-drilled holes, the diameter and depth of the counter-drill are specified. Specifying the included angle of the counter-drill is optional. The depth dimension is the depth of the full diameter of the counter-drill from the outer surface of the part. Chamfered and countersunk holes on curved surfaces. Where a hole is chamfered or countersunk on a curved surface, the diameter specified on the drawing applies at the minor diameter of the chamfer or countersink. Spot faces. The diameter of the spot-faced area is specified. Either the depth or the remaining thickness of the material may be specified. A spot face may be specified by note only and need not be delineated on the drawing. If no depth or remaining thickness of the material is specified, the spot face is the minimum depth necessary to clean up the surface to the specified diameter. Machining centers. Where machining centers are to remain on the finished part, they are indicated by a note or dimensioned on the drawing. Chamfers. Chamfers are dimensioned by a linear dimension and an angle, or by two linear dimensions. Where an angle and a linear dimension are specified, the linear dimension is the distance from the indicated surface of the part to the start of the chamfer. Chamfers specified by note. A note may be used to specify 45-degree chamfers. This method is used only with 45-degree chamfers as the linear value applies in either direction. Round holes. Where the edge of a round hole is chamfered, the chamfers are specified by means of a note, except where the chamfer diameter requires diameter control. This type of control may also be applied to the chamfer diameter on a shaft. Intersecting surfaces. Where chamfers are required for surfaces intersecting at other than right angles, the methods as shown are used. Key seats. Key seats are dimensioned by width, depth, location, and if required, length. The depth is dimensioned from the opposite side of the shaft or hole. Knurling for press fit. Where required to provide a press fit between parts, knurling is specified by a note that includes the type of knurl required, its pitch, the tolerance diameter of the feature before knurling, and the minimum acceptable diameter after knurling. Screw threads. The usual method for indicating screw threads is as shown. This method saves the time consuming work of drawing the actual thread. If necessary, a more realistic method may be used as shown in Figure 2. When left-handed screws occur, this must be stated, and in all cases, the necessary information on number of threads per inch, TPI, diameter, and thread form, example, Whitworth, BA, etc., should be given on the drawing. For more information, refer to our Screw Threads toolkit. Surface texture. Surface texture indicates the surface finish characteristics. They are denoted by symbols as shown. For more information, refer to our Surface Texture Toolkit. Gears. The usual method for indicating gear data on a drawing is shown. The core data such as gear and spline data are given on the drawing. For more information, refer to our Gear Data Toolkit. Location of features. Rectangular coordinate or polar coordinate dimensions locate features with respect to one another and as a group or individually from a datum or an origin. The features that establish this datum or origin must be identified. Round holes or other features of symmetrical contour are located by giving distances and directions to the feature centers. Click each tab to know more about location of features. Rectangular coordinate dimensioning (RCD). Where rectangular coordinate dimensioning is used to locate features, linear dimensions specify distances in coordinate directions from two or three mutually perpendicular planes. Coordinate dimensioning must clearly indicate which features of the part establish these planes. Rectangular coordinate dimensioning without dimension lines. Dimensions may be shown in extension lines without the use of dimension lines or arrowheads. The baselines are indicated as zero coordinate, or they may be labeled as X, Y, and Z. Tabular dimensioning. Tabular dimensioning is a type of rectangular coordinate dimensioning in which dimensions from mutually perpendicular planes are listed in a table on the drawing rather than on the pictorial delineation. This method is used on drawings that require the location of a large number of similarly shaped features. Tables are prepared in any suitable manner that adequately locates the features. Polar coordinate dimensioning. Where polar coordinate dimensioning is used to locate features, a linear and an angular dimension specifies a distance from a fixed point at an angular direction from two or three mutually perpendicular planes. The fixed point is the intersection of these planes. Repetitive features or dimensions. Repetitive features or dimension may be specified by the use of an X in conjunction with a numeral to indicate the number of places required. Where used with a basic dimension, the X may be placed either inside or outside the basic dimension frame. Series and patterns. Features such as holes and slots that are repeated in a series or pattern may be specified by giving the required number of features and an X followed by the size dimension of the feature. A space is used between the X and the dimension. Spacing. Equal spacing of features in a series or pattern may be specified by giving the required number of spaces and an X followed by the applicable dimension. A space is used between the X and the dimension. Where it is difficult to distinguish between the dimension and the number of spaces, one space may be dimensioned and identified as reference. Use of X to indicate by. An X may be used to indicate by between coordinate dimensions as shown. In such cases, the X shall be preceded and followed by one character space.